Okay, Tanner, Derek, good to have you both on the show. Thanks for joining us.
Thanks for having us.
Yeah, appreciate
Oh,
it.
it's great to have Apex Automation on mining now. It's a company that's had a lot of growth. So before we hand it over to sponsors and everything, Tanner, I wanted to kick off with you right from the beginning it is a company that's has expanded. You have lots of partnerships. So I just wanted to start with where you think that comes from, where that growth has come from, both on a technical side and a business development side.
Yeah, that's a great question. Technically, probably Derek might be better, but I'll answer where the visions come from and what's got us here. So in the beginning, obviously, Apex Automation was focused in Edmonton, Alberta. So process control is in our backyard, but our whole mission business plan has been to diversify our portfolio, hire the talent, the right person, train them technically. So a few years ago, Apex Automation started in 2012 in Edmonton, Alberta, and then we grew to Lloydminster and then Saskatoon. And one of the markets in Saskatoon is underground mining for potash. And that was a focus of ours. So along the way, we found some great talent, some great partnerships, and it's really helped us grow both personally and technically into that mining space, just to help autonomize the underground fleets, conveyance, and the unique position that Apex is in is that we're really good both with machine equipment, the mining equipment, and autonomizing that. And then once you're with the ore itself, we have that background knowledge coming from that oil and gas processing knowledge to help them process their own ore. So combining those talents together from the underground all the way to the surface uniquely positions Apex to understand both the mining, the processing of the ore, and then the digitization of the information for all the execs, if you will. So right from the mining phase all the way to the boardroom, Apex is uniquely positioned. And I think that's why we've experienced such great growth. Commodity prices are strong, and we generally try to offer our services locally. So we are willing to invest in local offices, in local engineering, and then our clients see that, and that's what they want. To be honest, they want to be able to, despite recent events internationally, it's they want that interaction with the engineers to work through the problems, the proof of concepts, all the technical data, if you will. So it's been
angles from different angles.
It's been a great journey for sure.
Yeah,
Absolutely. And from a technical standpoint, I would say that it starts with the people that kind of form our organization. We've grown a lot in the last 3, 4, 5 years, I guess. And one of the things that is really crucial to our execution is having not a wide breadth of experience within our team in the industries that we're working in. So in terms of local support, Saskatoon, our technical lead out of there has been in the potash industry for like the last 15 years, right? So as an example, like we're able to take that industry knowledge and experience and then apply, the technologies that we're going to be talking about a little bit more in this presentation to help them improve their operation. And that comes from a deep understanding of, what challenges they're currently facing and, how we can, evaluate, how to proceed and build a roadmap forward to increase their production.
Yeah, exactly.
Derek, I want to actually ask a question on that. Can you have one without the other? As in, can you implement these technologies without having someone maybe that was even in the industry before so much of this automation and all these sensors and everything came into play? How important are those people that have been in the industry before that so they really understand that on the ground process?
I would say it's absolutely crucial especially when you're starting to get into a new industry. You need to start with kind of a base of experience and knowledge about, the operations, right? How they're actually, how their business works. It's not to say that you can't, take somebody that's completely, green and fresh to that industry and, bring them up to speed and then they can start adding value. It's just going to take a lot longer. And it's not really appropriate, I would say, for a new industry that you're trying to break into.
Yeah, the clients are looking for results for sure. And the combination of that operational experience and then just a fresh set of eyes from a technical standpoint really has expedited some of the machine vision things that we've done for underground mining and surface mining and so on and so forth. So that collaboration is critical. And we always say here at Apex, you know, we work for operations. And I think that's critical because we want to understand how the operator operates the machine. We want to understand how the operator is you know, working his, you know, his system, his control room. So once we understand that, we can start filling and giving back his time. We always say that we want to give the people back his time because sometimes they're so overwhelmed with inputs in their daily jobs. We can autonomize some of those things. The semi-autonomous roadmap towards fully autonomous, where the operator is running several machines from a control center, and he just kicks it in the manual because those machines will always get stuck. They'll always have an interruption, and he can get it out of that uncomfortable position, click it back to auto, and that thing keeps digging. So that's the vision. But those operator stories, that experience, that collaboration is required for us in order to develop the sensor integration, the logic, and the data visualization.
And it's not to say that, you know, there isn't things that we can bring from that, you know, maybe weren't as commonplace or typical in the industry and bring them in and add value, because we certainly do that. And especially around processes.
Yeah.
You know, part of, I think a big part of our success, especially in kind of our process industry before we really started getting into mining, was around how we would execute our projects. So in terms of our QA processes, in terms of, you know, the experience for the customer, when, you know, they get to see that final product before it even comes to site and interact with it and understand how it's going to work. And there's just that confidence that by the time that we actually go on site to commission, that our probability of success is quite high.
Yeah, they get to play with it. So we do a whole sort of simulation, and we have labs. We invest heavily into our labs. So we integrate the sensors, we do the logic, we put the HMI or the graphics up, and then the operator will sort of play with it. And we'll go through a whole testing sequence. And then they're like, okay, this will work. Let's go to site with it. So that workflow was, we found fairly new. They always had a little bit of a research and development, but the QA QC was something we brought to the table, and they really liked it. And they just felt that because you're interrupting an operation to test. So, you know, you can imagine.
One or another, yeah, always.
Yeah, so imagine commodity prices right now, and you're interrupting this process. It's going to be like, well, how long are we going to be down for?
Right.
This is going to commercially affect us. So going in and having a simulation test bed is super important. And we invest in our own labs on behalf of our clients. So sometimes it's like, well, who's going to buy this piece of equipment? Apex is like, well, look, we got to do 50 more of these. We'll invest in it. It's no hard feelings, and we'll just go ahead and test it on your behalf. So I think that understanding both technically and understanding the commercial and the cultural, the operator experience has really led to just better authentic communication with our clients, and led to ultimately the success of our successes in the proof of concepts and successes in standardization and autonomizing their equipment. It's a working machine, if you will, and a lot of moving parts for sure.
I like that. I will say that giving people back their time tag. I thought that was quite I love it when companies identify just a clean way to say what they're trying to actually accomplish in a few. It's a very good tag. Gentlemen, I want to kick off to some of the training topics. We're going to talk about some of your partnerships. We've got a ton of stuff to cover. Before we can go any further, we have to give a shout out to some of our sponsors. So I'm going to hand it over to Gaudy, and we'll kick the interview back off.
Okay, so let's start off with Zero Knox. Zero Knox is a global leader in electric powertrain solutions, microgrids, and clean technology. They provide a platform for clean energy technology to come to market through powertrain solutions, development partnerships, and electrification kit solutions for conversions, all powered by Zero Knox. Their mission is to empower communities through sustainable innovation as they partner with some of the world's leading OEMs to solve challenges across multiple continents with cleaner and higher performing technology, empowering a clean, innovative, and higher performing future without compromise. To learn more, you can visit them at zeronox.com. Next up, we have Railveyor. Railveyor's truly autonomous material haulage systems reduce transport costs up to 91%. And because Railveyor is fully electric, it produces zero direct emissions. The truly autonomous system enhances health and safety by eliminating exhaust fumes and enabling remote monitoring of operations. And of course, Railveyor isn't merely a concept or pilot program. It's available right now and is being proven in a growing number of installations around the globe. You can visit their new website at railveyor.com today and step into the future of mining. Next up, we have Savannah Equipment. Savannah Equipment supplies new and used mining equipment around the world, from placer to underground ore processing plants. They have gold concentrating tables, trommels, and mineral jigs in stock now to take advantage of the high gold prices. You can visit them at savannahequipment.com, where you will find more equipment every day. Next up, of course, we also have CIM. The CIM 2022 Convention and Expo is coming back to Vancouver in person this May 1st to 4th. Show off your products and services in mining technology, digitalization, equipment, consulting, and engineering. There are a whole lot of perks waiting for exhibitors, and this expo will sell out fast. If you're a researcher thinking about what mining will look like for future generations, this convention is the perfect place to present your technical paper or lead a short course. Visit CIM.org for all the details. Book your exhibitor space and submit your abstracts today. And last but not least, we've got Mining for Miracles. This year, Mining for Miracles is eyeing the completion of its commitment to raise $3.385 million to establish the Cellular and Regenerative Medicine Center at BC Children's Hospital to better understand the genetic cause of heart arrhythmias in children. Get involved or make donations at miningformiracles.ca.
Okay, I'll actually let you choose who's going to answer this. I want to talk a little bit about the training in these, like when you're bringing, because I see like you have like partnerships with companies like Rockwell. I wanted to sort of understand your onboarding process of taking on new software, new technology, getting your team up to speed, and then redistributing it out to the industry.
Yeah, I can definitely speak about that a little bit. So I would say that, beyond the administrative stuff, which we obviously won't get into in this, we start with an industry-specific onboarding. So that means that, even if somebody's new to the industry that we're bringing on, that hasn't spent a lot of time there, we're going to make sure that as a starting point, before we even get into the technical details, Rockwell, our sensors, whatever, we want to make sure that they understand, at least at a high level, how the client's process actually functions, because that's going to give them a lot higher comfort level even the first day that they spend on site with the client, or even in a meeting if they're working from the office, right? Again, understanding our client's business is, I think, key to our success. So that industry specific onboarding would be a 1 to 2 day kind of approach, where we would go piece by piece. These are the different mining patterns we're using. This is, what, I guess in terms of like how the shafts are laid out. This is, how I guess our communications are going to be working underground. Like all these different, things that you need to know that might not be directly related to the technical solution need to be addressed. Once we've done that, then we kind of set up an outline of a certain kind of baseline of Rockwell training courses, that we have access to through Rockwell University, that that a new person that's joining our company might or have to I guess view online, right? Like they might have to do that training depending on whether they're coming on as a junior, intermediate, senior,
Yeah, depending on their
right.
yeah.
So we assess that at the start and say, well, we think you could use kind of these baseline topics. But in general, that's one piece of it. Another piece of it that we find very important, and especially when it comes into more advanced applications beyond just a simple PLC with IO connected, you start getting into autonomous mining, you start getting into analytics, stuff like that, is a good understanding of IT infrastructure. So another partnership that we have is with a company called Stormwind, and they're helping us to provide certain IT specific training to our systems integrators, so that they're fluent in that as well. So it's not just controllers and instruments and
it's
valves.
a network. You can imagine
networking.
you can imagine underground or even surface mining, getting access to that data. We can program it. That's great. We can integrate the sensors, but okay, now understanding how we package that data and send it maybe to a cloud server, or get it out from underground mines to the surface through Wi-Fi and Tropos points, and troubleshooting those things is something we're actively in. I mean, networking it's funny, you go to school, you learn all about the sensors, you learn all about the PLCs and the DCS systems, and then you get out there and you're like, hey, do you know anything about this router?
Yeah, and it does.
Like, wait a minute, we haven't taken anything.
The hangups are sometimes the pain points in technology. I mean, we see it in production, right? You can buy literally $500,000 worth of equipment and you're missing one adapter and it doesn't work. It doesn't work.
We experience that on our side quite a bit, especially with legacy protocols and coming into new standardization, Ethernet IP, TCP IP, so on and so forth, MQTT. You've heard them all. So anyways, that is something that we obviously actively now participate in training our staff. Like, great that you're good PLCs and HMIs. What about your OT and IT architectures?
So what do you? Oh, sorry. I was just going to add a little bit more on top of that.
Go ahead.
Go ahead. So so on the OT side, we'd kind of be platform specific on whatever kind of system that they're going to be working with. In the mining world, we're definitely big into Rockwell, but also Delta V as another example. Yeah. So we have some onboarding relative to the platform that they're going to be working on. Yeah. So that covers the OT space. The IT space, again, we have Stormwind.
Sorry, what is OT? What does that stand for?
Oh, sorry.
It's okay. I figured that question was coming. So in our world, you can imagine operating technology. So we don't necessarily need the infrastructure technology that we use day to day in the internet, that side of things, the printer. The operating technology would be a console in a control room, talking to a controller, talking to a device or a machine. Well, how we set that network up is different than how you set up an IT infrastructure. So it's a little bit more simplistic. It has some cybersecurity initiatives. And then we put a firewall on it so to protect all the assets, all the machines in the field from hacking, from just having all this extra, we'll say, parameters activated that we don't necessarily need. And so that's the operating technology. So when you talk to geeks like us, the OT side that's your mining face. That's your oil well. That is, that's the active operator on a machine. We would design a network resilient to make sure that in a storm, cables are cut, we still get the data out of that machine. And then we spoon feed it up into the corporate data network where they can do reporting. They can make business decisions. And that's what we call the IT side.
So exactly. When you're talking about networks and servers that'll interface with the control system, that's what we mean by the IT versus OT.
That's right.
Yeah, it's amazing that someone with my lack of skill gets to do a show like this and gets to talk to gentlemen like you. But you know what? It's a great learning experience. So something I was wondering, actually, my wife is handling a program right now that's onboarding people into the tech space, and so I was wondering if somebody's coming on a very junior level. Are we talking 2 years for working for the company before they would able to be part of that implementation team for, a Rockwell system, or,
You might get two different answers here, but I love the question.
Yeah, no, sure. Yeah, let's unpack it a little bit.
Oh yeah. So in my experience, a really good automation engineer or technologist, it's a 5-year growth to get to the point where he'll be a senior or somebody that will be trusted with multiple facets within our work. Is
this someone already with a degree? They're coming out of university.
Coming out of school still takes 5 years.
Okay.
So in addition to that, though, we as a team in leadership, we assess his skill set, his being, his soft skills, who he is as a person, and we position him during the interview process. There's two things: we assess the person, like I'll meet him for the first time, and then Derek will meet the technical side. And the whole ambition there is to position he or she into a position of delivery, so they feel like they're being part of the team, whether that's building graphics, whether that's even monitoring, doing the quality assurance sheets for checking off our items during the testing phase. But we obviously, as management team or leadership team, we ease them into it. During that phase, they'll get into the controller and the logic. Then they'll learn the HMI and the graphics. And then with Derek's help, they'll learn the networking, on the OT side. And then when they keep going, they're going to learn C++ and VBA and Python for the data visualization side. And now everything I just said to you, that's 5 years.
5 years.
I would say 5 years would be a minimum. If I was to throw a dart at the dartboard, it'd be more like 10. I would say that's like a really high level senior. But I mean, at the same time, I was also going to answer that you might be surprised at how quickly a new resource can be ramped up to add value, because ultimately, some of those junior resources, they have no barriers to beginning to learn on a specific topic. Obviously, school is preparing them for difficult things that they're going to have to master eventually. Programming, learning how like the electrical design works, all these, networking, these are all things that are critical for our execution. But, what you'll find is that the juniors, they really have they want to learn, and they have a very high appetite to learn. So with the right guidance, they can be providing value in certain capacities to our clients, in a matter of months.
Yeah, one quick thing is, one thing I personally noticed is with the programming languages being readily available in the internet. Python is another one I keep bringing up. These younger people, they're already versed in it. They're taking it in high school. It seems to be a passion already. So when they go to university, learn the electrical side and maybe the processing side, they're like, hey, I can do Python, I can do C++, which really sets them up for success when they start learning our other languages like ladder logic, function block logic, to make these machines autonomous. So the combination of the two skill sets, again, that OT, IT convergence is what it's called in our industry. The new engineer coming out of school, I feel, is the best prepared engineer I've seen in the last 20 years to really take this autonomy to another level. It will happen. We're in the semi-autonomous state now. In the next 10 years, these new engineers will get it to the finish line. There is no doubt in my mind.
To build on that, how in the 20 years ago, a lot of this was new, completely new systems that were starting to get implemented or even tried or even developed. Now we're in a stage where it's being used. So is this how do you say it? In 10 years, will there, and I do not understand how to develop any of this stuff. So this is a wrong question. Is there a whole new system that's going to get developed? Or from here on, are we at a point in an autonomy, especially in the mining sector, where systems are getting built on and they're getting expanded within these confines of what this operation is?
Yeah, it's a bolt-on. That's what we're experiencing right now.
Absolutely. It's a layering of existing technology. So you may have heard of the terms kind of Industry 3.0 and Industry 4.0 and digital transformation and all these.
That's right. Yeah.
What that actually means is that, we're adding layers on top of existing technology to bring data and make data available to systems that previously did not have access to that data. And now it can be combined and compared with data that, lived completely outside of the control system. And, you can put that to a new use, right?
You can think about it like just a use case study. You got all these, farming equipment out there, and they have a little controller doing the hydraulics. Maybe it's manually, or maybe it's some autonomy in there. Those were isolated little networks, right? Device going to a little controller, talking to the operator locally. Well, now with, Industry 4.0 and 3.0, it's been networked. So now all those machines in the field, the farmers can keep like what their run status, the time, the maintenance of those equipments. We have all that data that we can use to help the operators make better decisions. So that's where we're going. That's what it is. It's been bolted on over the last 20, 25 years. And now it's going into another space with the cloud and with new libraries for machine learning available. You can make actual decisions. People don't have to necessarily do them. They can apply their knowledge to the code. The code will make a suggestion, and maybe we just say, yeah, that's a great suggestion. And then it says, okay, I've got the right answer. That's machine learning. And then it'll just go to auto, where it says, I'll make the decisions now. And if I don't know, I'll interrupt you, the user, the person, and say, hey, what do you think I should do? And that's where the libraries are at right now.
Remember this, sorry, I was just going to add, like it's not a wholesale change of the entire operation. A lot of times this builds up just from kind of small applications.
That's what I was going to ask, that integration level, that integration process, now switching it over to the actual, the mining operation that you're in.
Yeah, absolutely. So what we tend to do is we will, kind of pick, an area where, there's definitely already, a value that would be there in terms of, if we could add autonomy to this function, the business value is already there and put in place. And then we would start to look at, okay, the technologies, that we would use to address that, how can we proceed from that point? But it always starts from the business case, right? It doesn't necessarily start with just bolting technology on and hoping that you get the value out of it. Right. And so that's the thing, is like, we often start small. We start with proof of concepts. We start with a problem that has been outstanding for a long time and look at how we can apply maybe new sensors or new technologies to kind of, take a different angle on it, right?
Yeah, the two things we find for justification, talking with clients, right? Identifying operational excellence opportunities, as you will, is safety and their people. They're looking after this. They want to look after their staff. They want to look after they're seeing equipment and people being hurt. So autonomy can solve that. The other one is also what Derek alluded to, was the commercial justification. Hey, if this guy's doing this and he doesn't have to do this simplistic task, repetitive task. If you're doing a repetitive task, that's the low-hanging fruit on your autonomy program. If this guy's hitting the same button, sitting there every day, all day, we can autonomize that instantly. So, and then he can go off and do something else, make it more safe, clean up his work area, do things like that. And so that's,
or run multiple machines.
So that's where we help our clients identify. Sometimes they already identified it and they just need our help to commercially justify it to even their superiors. So that's what we do a lot of, believe it or not.
Yeah. Well, I was going to ask about that. Is that Derek, you kind of touched on it already, is that they're already identifying a problem. Is that the case most of the time where they're saying, we have this, we know this is a waste of time, or we know this is a high risk area and we want to fix this. We don't know how to fix it, but we want to. Or are they coming and saying, hey, look at this and see what your ideas are? Like, how is it sort of a balance of both, or is it the first one more often?
So here's the thing. I would say currently a lot of it comes from that angle where they have a business case, or at least they have an area that they've identified where it's like, we know that if we we're able to make add an autonomous function to a machine, that we could run with a slightly smaller crew, or we are going to have improvements in safety, we're going to have improvements in reliability, all those things, right? But another piece, in terms of analytics, is providing customers the ability to come up with those business cases or identify those opportunities a little bit easier as well. So that comes from having data available, right? And so that's another kind of aspect to it, and that's where I see potentially a lot of growth as well. Is deploying the gateways, the data flows to bring data from the machine to analytics software and allow people to kind of make those comparisons and come up with the additional use cases. But yeah, for now, I would say a lot of it has been from a pretty well-defined business case.
Yeah, for sure.
Let's turn this into real world now.
A lot of buzzwords.
Let's talk about some. You've actually provided me with a couple projects, so I wanted to highlight. There's an autonomous positioning system for ore and material management. Can we talk a little bit about that? I think we've got a video that we can play, and sort of walk us through what we're seeing and what the function is.
Okay, so I guess I can start out with this a little bit. So the ask from our customer was to start working with them on an application to automate the dump point positioning on a mobile conveyor. So basically, prior to having any autonomous functions in place, operator sitting there with remote control, and he's deciding where the dump point's going to go. And as the machine progresses forward, it goes over humps and bumps and twists and turns, and that dump point's moving. And so that was something that they said, okay, well, right now it's basically a full-time job for somebody to baby this. And we said, okay, like we'll start looking at ways that we can, develop an application to automate that. So it starts with a bit of a, first off, obviously is to, get your objectives in order, right? So we need to understand what conditions that this machine's going to run within, your operating window, so to speak. How much tilt are we going to account for? How accurate does our positioning need to be? All of those questions, are kind of reviewed, and then we could start coming up with kind of a proof of concept or preliminary solution, right? We'll have a kind of an initial set of sensors or actuator changes, plus the controllers or computers that need to be added to make everything talk. So we did go through that process, and in that particular instance, we ended up using a laser scanner technology to add additional machine vision. So we're talking about a 2D point cloud, right? We're finding the belt where we're supposed to be dumping using a laser and actually multiple lasers.
And it's unique. It's unique in its placement because you can imagine this is a big miner underground mining its ore, and the ore is going over a long conveyor that's moving along with the machine. And at the very end, it dumps onto a panel belt. And so that's the dump point that the operator is operating. And historically, you don't necessarily want to use a laser. And the only reason I'm going to say that is because of all the dust lasers can't see through a cloud.
Yeah.
But because it was so far back and they had some pretty good dust control, the laser gave us the granularity that we were looking for positioning, right?
Yeah.
It gives us a nice 2D point cloud. So then they can take that X and Y coordinates and autonomize that dump point to stay over the panel belt. And so that operator that was sitting there repositioning it with hydraulic control and a little remote, you didn't have to do it anymore. So that was one of the instant successes, just by identifying, going through that workflow and identifying the sensor we needed, the machine vision we needed, networking it into the PLC, and then building an algorithm in an edge computer to self-adjust with some math based on its staying in the center of the panel belt at a high level. It's basically
and maybe like I'll expand a little bit, obviously without going really into the math. Although I'd love to go into the math because that's
No, I could see it. I'm like,
yeah, but I'm
I'm like the referee here.
yeah, totally.
Generally speaking, the approach that we took with this, and of course, it turns out that as you go through the project, you realize there's probably more sensors than just the laser scanner. It's a system, right? And that system, ultimately what you're trying to do is you're trying to create a digital model of of the current state of the machine, and
Right.
also where you expect that it would go, what state it would go to, based on changing your outputs, right? So ultimately, like that solution, that's what it does. It has a model built into it, and you could use the buzzwords to describe it, digital twin, whatever you want. But ultimately, there's a model, there's data that gets passed to the model. It determines where the new best positioning needs to be, and it gets sent back to the actuator. And I mean, or to the positioning system, right? Which is actually a motion controller in that case. But I mean, the thing is, ultimately, throughout that whole data flow, there's quite a few different pieces and steps. And that's the part where Apex helps out with our clients quite a bit, is that, we'll help determine what's the best interface to get this sensor's data and condition it, and then make that available to a PLC. Because, just to use an example, like a 2D laser scanner, a PLC is not really the best device at all to process that data. Oh, and a lot of it has to do with being able to leverage libraries, from C++, Python, the vendor's APIs, whatever it might be, to process that data and condition it and send what needs to be sent to the actual control system. So there's, with a lot of these kind of more advanced applications, you end up with this relationship between an edge computer and a PLC.
Yeah, and the fun thing about it is, I've been asked this, like, is there anybody actually out there using edge computation? Is there anybody actually doing that? And believe it or not, there is. Apex Automation in Western Canada, we're doing it, and we tend to be a little bit of leaders in it. So it's been really exciting over the last few years to get into that space.
That in a system like this, because again, probably on the production side, I have a good understanding of the, just a camera isn't enough. There's about 30 pieces of gear behind it that make it all operate in sync. Is that still a pain point when trying to communicate what needs to be done? That they go, oh, we're going to use lasers. Okay, that's great. And that's going to, if you're talking to someone like me and I was making the decision, I go, okay, that's great. So we're going to scan it. It's going to be a digital twin that's going to go into a box. We're going to plug a cable in. It's going to go back to our data center, and we're going to monitor. Sounds easy. Like that's, I'm sure that's happened. I'm sure that's happened to you. So that understanding of just the levels that it takes to get to that end result.
Yeah.
Is that still a challenge to communicate?
Absolutely. And part of the challenge, I would say, is that, a lot of times these solutions are not, cookie cutter by any means, right? It's specific to the application, right? So there's a certain amount of development that needs to take place. And, I guess the way that project would be structured might need to be communicated a little bit different with our clients. And I think.
Yeah, exactly. So that goes back to the successes of Apex Automation. I mean, the two is we technically deliver, and the other one is cultural communication. Yeah. So when we go into these type of conversations, we identify you have a unique mining environment here. You deviate from the norm. So in that case, we're going to do a proof of concept. And one thing Apex does is we go through decision records. Let's use the best sensor. How do we determine that? Well, it takes R&D, but we have experience. So now we've already got filtered data for you. Which sensors are going to work good in this application? But let's say it doesn't work. let's say we recommended one as your consultant. There's a decision record that we all agreed as a team saying, this was the sensor for us. This is how we're going to do it. For Apex puts its money where its mouth is. So we actually rebate if we go down a trajectory where it doesn't work, we'll say, okay, this is a relationship. This is where Apex needs to step up and say, okay, we did that as your consultant. And as a consultant, we were probably pushing the wrong way. Let's recenter and go with that other sensor we knew was a close second and reevaluate. And then we'll rebate the engineering hours to go down this road. We'll get back to center and keep going. And because of that type of communication and that type of partnership, I felt it broke down a lot of commercial barriers. They're trying to say, well, how can we always get stuck with the bill, even though we want to go autonomize this thing? Yeah. Apex is willing to put our own investment into it to say, yes, let's do this. We want to do it. Let's get it across the table. So we warranty, to a certain extent, proof of concept work, which is probably crazy to some, but for us, it's an investment. We want the client to be a long-term client. We're not here just to do one thing. It's going to be, let's do this one thing. What's next? So in order to break down that barrier in a relationship, you got to sort of go into it like that, a relationship. So,
if I had known that you did that, I probably would have led off the interview with that, because that's a selling point. Wow. Let's go into this. There's a remote control room, and I've done, sensor technology and that, and for whatever reason, I've always had a tough time getting a video of the actual control room. I get that people have to go on site, and they there's always these NDAs and all that type of stuff. But you've got one, so I want to play it. So it's actually shown an actual control room of I believe it's an underground mine.
Yeah. So what that is to be the teleremote center. So what they've done is they've given access for basically their mining operators don't have to necessarily sit on the equipment right now. The vision there is they can monitor equipment from afar, make adjustments in like a cyber chair with joysticks, and move those equipment from the surface. This one in particular is an underground mine, but you can imagine those integrated control centers or teleremote centers, they are the future of mining. I mean, you're going to have HR personnel that don't want to live in the Yukon, but still have the mining operation know-how to do that equipment. So why not give them the ability to remote access that piece of equipment, drive it with cameras and sensors, and give them the data back they need in order to operate. So that's what you're looking at there in that video, is the first step to getting the operator from the face of the mine to a logistical friendly control center. And so it's pretty unique.
And of course, there's a path, right? It starts out, maybe you're just out of the drift, right? You're just, back from the machine a little bit. And that even has like immediate safety, impacts and, reduced hazards. But then eventually, as you get more and more comfortable with it, you're further along in the proof of concept. We start centralizing, somewhere on surface.
Right? Yeah, exactly. And then they no longer have HR issues as well. So there's a whole bunch of nice, commercial, HR related justifications for even going with a technical solution like that. It helps their business overall. Right. Yeah.
And all you need is a couple sensors and good Wi-Fi connection.
I'd like to say you need Apex automation, but you do need that network thing we were talking about before. That's the critical piece, is understanding, like literally wire sharking their network, seeing how resilient it is, how much data we can pass through it, because there's a lot of data coming from those mining equipment that the operator is going to need. And if you don't have a good backbone, you got to start there. That's where we'll come in, assess it, and help build that up first, and take it to the next step.
Like an operation like this, like how many data, what is the amount of data even per minute, and the amount of data points on something like this?
That's a great question.
It's definitely it's in the probably tens, if not hundreds of thousands of individual point parameters that could be on a machine, and it's only going to grow, right? Because more smart instruments are being deployed, right? We don't want to just get a pressure reading anymore. We want to basically get enhanced diagnostics. We want to know has the actual like sensor itself failed, or is it an issue with the transmitter? And not only that, but maybe be able to configure it remotely, right? So each time that we make each individual small component a little bit smarter, you've increased the number of tags and data that can possibly be there, right? So then you also need to have an efficient way to get that out. Part of it is obviously having, a solid network backbone, but part of it is in the technology and protocols that are used as well. So
yeah, and thankfully the IT, so the switching companies, routing companies, they have really expanded their own devices. Like when you go buy a router off the shelf, they used to be 100 megabytes. Now you get gig per port. That gigabyte per port is great for guys like us, because then we can marshal as much data as we can through that pipeline and get access to it. So
is bottleneck still an issue then, like on these remote sites, or is the technology up to par now that you don't have these types of bottleneck issues? And I again, very rudimentary.
It depends on the
I used to work out on a remote site where there was real bottleneck. You'd add in 2 more computers and you'd have bottleneck issues.
Absolutely. Yeah. So wireless technology has come a long way from what I've seen with my experience in the industry. There's a lot of really cool mesh technologies out there that are enabling you to, kind of get, close to those gigabit speeds, but also have, a cluster of devices that can communicate with each other. So you're not, you're reducing your number of single points of failure, right? And also providing general Wi-Fi access in through a large span of your operating area, right? But another thing related to that is you're starting to see new technologies to get physical networking, right to the machine as well. So like, fiber to the machine, stuff like that is being started to become
Yeah, the bigger mining companies obviously see value in the IT, the infrastructure technologies, and deploying fiber, and then getting mesh networks out there, resilient networks, so that way they can get access to the data of the machines. I mean, some of the, we'll say medium and smaller mining companies, yeah, I'm sure telemetry and access to that data will be still a hindrance to them, especially at a cost-effective commercial manner. But again, you get Starlink and some of those type of techs coming from satellite. I mean, that will give you access anywhere in the world.
Yeah.
Right. So then really, again, in a few years, you're going to have even the smaller producers looking for, okay, we can network our machines. What can we do with this? And they'll be calling us.
Will you ever see a day? Will you ever see a day when like small operators could operate under a cluster? Like 10 small operating mines could operate under one control system from not even a parent company, but a parent organization that can actually run this system?
I agree. I think you can. And the reason why is, we're working with some equipment manufacturers for autonomizing some of their equipment. So the data is going to be there. I think as you buy the new machines or lease these new machines, they're going to come intelligent. So then all you need is access to that data via SCADA, radio, satellite. And then you can bring that back to a centralized control room or a centralized database and do whatever you need to as a producer.
Right.
So those days are coming. I mean, you actively look at what CAT's doing, Finning's doing, some of those equipment manufacturing, and they're looking at trying to offer that to their clients, right? So I see it now. So I feel in the next five years, you're going to see a lot of that sort of deployable, like Tesla and the autonomous cars. It didn't take long for the industry to catch up, and they have access to those cars anywhere in the world. So it's coming at a high velocity for sure.
And going back to if the infrastructure and the programs and the way of doing it are already in place, it's easier to build off of. We're not starting from zero on these systems.
Exactly. So then, the big mining companies have had to go through industry 2.0, 3.0, 4.0, and they've been leaders. Like, it's not any discredit to them. They've led industry towards that. That's usually how it works. Yeah. The smaller producers who have a good maybe reservoir of commodity, they can just invest in industry 4.0 right out of the box because the machine's ready. It's industry 4.0 ready. And so they just got to literally plug it in.
Yeah, you see that in remote places with internet access.
Because they don't have to worry about modernizing their legacy fleet, right? So,
that's right. Exactly.
Yeah, interesting. How long would it take? I know this is a loaded question, but how long would it take this control system that we're seeing here, this control room, from first conversation, hey, we've got an idea of what we'd want to do, to, oh, this is operating, and of course you're always going to be updating and refining it, but would this take a year, 2 years? What would this?
I can tell you what it's taking right now as a general rule of thumb, but I want it to be faster.
Yeah, and I can tell you, where it started and how long it took in the very beginning. So I'll let Derek go first, how long it's taken right now, but then I'll give you the whole timeline from the very beginning afterwards.
In generally speaking, you're looking anywhere from like 6 to 18 months, I would say, generally speaking.
Yeah, and then in the beginning, from a proof of concept to where it got for the very first one. So this one in particular, you're going to look at a couple videos there, but they're two different one's teleremote, so one's doing mining, and one is actually integrating, you'll say, your surface ore processing. That's integrating multiple facilities into one. So that one is the ICC, and it's a unique video. But I'll speak to the one that we're talking about, teleremote. So in order to go teleremote from concept to finish, I would probably be a year and a half to 2 years, to be honest. But if you have a repeated, once you want to do it once and you want to repeat it, if you have multiple mines that you want to integrate to the surface, then you have a 6 to 12 months window, depending on lead times of materials. But we've already done it once. So I think Apex has done it once. For other clients, new clients, we could probably expedite that timeline, but that's a realistic timeline because every client is unique in their infrastructure. We have to do a baseline assessment, like a feed study, front-end engineering design, or anyways, get in there and discover what they have, what they need. Once you got that backbone, then we can get the concept. If they have the backbone, it's expedited. So that's the biggest trick to that.
Yeah. No, if you had said 3 months, I would have been like, oh, sure.
Yeah. Well, the way that you're talking about it, it sounds like it is. No?
Yeah, exactly.
Super easy. Just plug the plant in and bring it to the
couple
surface.
of sensors here.
I apologize for anybody that is like me that has been the decision maker in any of your projects. So now this other video you sort of touched on is this is showing a whole system of hardware and monitors and looks like different room locations. Give us an overview of that.
Yeah, so that one in particular is the ICC. And to put it into layman's terms for anybody watching, like mining, maybe you have multiple mining facilities, and those facilities will already have a control room in it. Like if you go in potash processing, for instance, just because we know it so well out of our Saskatchewan group. Each mine has an ore processing. They're washing the salt out of the potash and getting the refined potash. They have a control room there. Now, if they wanted to say, hey, and they have 5 or 6 mines, one client all over Saskatchewan, they said, hey, you know what, we have guys living in remote towns and we're having HR issues, or we feel like we could have access to the operational team, easier access to better data or better decision making. Maybe they want to consolidate those 5 mine control rooms into one. In Saskatoon, for instance, you can do that. And that's what that ICC is doing. It actually took 4 processing facilities and integrated it into one. And what you're looking at is basically 2 consoles, operators surrounded by monitors, but those are multiple facilities. So he's looking at one facility here, one facility there. He can switch screens, move trends, and just keep an eye on multiple facilities from one chair in an actual urban center.
And you can imagine that if you had multiple operators, each controlling multiple sites, and they're all in the same room, the collaboration aspect starts to really take hold.
Yeah, your efficiencies go up.
And the efficiencies go up. And not only that, but it becomes plainly obvious when you have discrepancies between sites.
Yeah. You're like, okay, there's a problem here. And that really gets you one step closer to what everybody really wants, is that Industry 4.0, making decisions. So then once you have that data centralized, right, in an urban center, we'll just say Calgary or Vancouver, then that data is centralized. So then that operator is going through the processes of operating that. Okay, now we can get to understand his operator experience. Okay, so what can we take off of your plate to be more efficient? And we'll automize that decision for him. He doesn't have to click on it, manipulate the set point. We'll understand his story, use the libraries available to us, and we'll make the decision automatically. And that's really where you're getting into your neural networks and machine learning, to be honest. And then ultimately, what everybody's sort of shooting for in the next 20 years, your AI. So then the operator is sitting there, just in case there's a problem, he knows how to operate it, but it comes up, warning, don't know what to do. And he jumps in and comes in. But for the most part, he's sitting there and monitoring.
Right.
Yeah.
So now going into some of these companies you work with, like NavTech Radar, and companies like Rockwell, these are they delivering products and solutions that you're implementing that are already geared for 10 years from now? Or how are they sort of finding that balance of solving the solutions that are available today, but then knowing what's coming tomorrow?
That's a great question. And it sort of coincides. And that's why we're here. As consultants, like NavTech Radars, we've just signed that deal with them. We're a distributor and a service partner for them. And in particular, that partnership's really exciting for us because they sell an OEM sensor, a radar. And again, LiDAR is great if for 3D pick point cloud analysis. So that's what Tesla uses to keep your car straight on the road. But the problem is, everybody says this. What about in a storm? What about a gravel road here in Canada?
Sensor gets covered in dust?
What if the sensor gets cut in mud? So radar has the ability to see through that. So, in industrial spaces, like what we're dealing with in mining, heavy industry, radar is our preferred sensor. So we can take multiple radars, right? And we can build our own, we'll say, point cloud with those radars and then make position judgments or decisions based on that data. So the NavTech builds a pretty good hardened industrialized radar that we then can take and integrate into a Rockwell PLC, a Siemens PLC, a Schneider PLC, whatever brand it is, and start developing a solution. Now, NavTech in particular has its own solution for I think it's called 360 terrain. And they actually scan to make a 3D image for a vehicle to actually autonomize, honestly, military equipment.
Yeah, I saw that they've got a military background. Yeah,
exactly. So that's the military again invests heavy into R&D. So you always see the first cool feature like drones in military applications,
right.
And then you'll see it in industrial applications, and then it gets commercialized for the general person. That's been the workflow of research and development for 50 years. But yeah, so in particular, NavTech is in a unique position to give us the sensor we're needing in order to autonomize for our clients.
But also provide the tools and interface for us to develop whatever solution we need to.
Yeah.
And it isn't a closed box.
So yeah, exactly. That's the biggest thing is our solutions and IP, we don't retain it. On the commercial aspect, another differentiating factor, we get asked this question all the time. Okay, so we develop a solution together. Yep. Do you guys retain the IP? Nope. we don't care about it. We're a service company only. We want to help you achieve your goals. You retain the IP. If you want to put, intellectual property rights on that and then go distribute it in your corporation worldwide or sell it, go ahead. We want nothing to do with it. So we're just introducing the technologies, constantly learning in this space through professional development to take a look at new technologies, align with partners, and then offer that as a consultant to our end users and clients.
That must be, and that's a nice thing for companies that you're working with that are like the NavTechs, because they're trusting that you're just using it basically their products at the how would I say it, at the most pure level possible, because you're just using it to integrate into a system that the customer needs.
Yeah, we expand their industry verticals all the time.
Right.
So if they're in the military zone, but they're not necessarily in the mining or ports and terminals or grain terminals, we're bringing those clients to them. And so that's why it's such a great and unique partnership, is they gave us the ability to go to our clients and say, we have a solution, we have a proof of concept, let us do it for you. Grain terminal loading, ore loading, all that, ports and terminal loading, that's part of it. It's called pit to port. And Apex is uniquely positioned for that pit to port dream. From the mining phase to loading a ship in Vancouver, we can help you autonomize all of it.
Yeah, it's absolutely amazing. We kind of talked a little bit about the future, the sort of the future technology, but before we wrap up the interview, I wanted to just kind of expand it on a little bit. And again, I'll let each of you sort of pick. Where do you see it going? We touched on a little bit, but just sort of some other technologies that we should start keeping an eye out for.
Yeah, so I guess like in my opinion, where I see it going is remote operation. That's kind of where we're at right now, and that's where we're there's still a lot of development going on.
That's very new.
But full autonomy, right? And basically unmanned operation is ultimately where we want to go, right? And then once we have that, right, also centralized data, centralized analytics related to all of that is going to allow us to keep gaining additional efficiencies as we go forward. So yeah,
some of the cool ones that I see are immediate sort of future technologies, but it's sort of one of those things. It's a cultural, like, why do we need that? But you can
augmented reality,
like AR. It's I put, we are a partner again with RealWear, and it's literally a wearable tablet It has a little screen, it flips down. We've seen them out there. Nobody's really keen on it. But when you actually take a look at what it can do, so imagine you have these centralized control rooms like we were talking about before. You're still going to have maintenance staff and people deployed when a work order comes out or routine maintenance thing comes out. So identifying the fact that, hey, an operator or an engineer can get access to what that person's seeing in the field, that's called connected worker. And RealWear and PTC, which is a partner of ours as well, they have augmented reality libraries available. So you log in, I got this little thing that flips in front of my eye, and I'm saying, hey, unplug this fuse. And he literally sees it on his screen, and it's through digital AR that he's seeing exactly what to do. He has the knowledge to do it. It's collaborative between all parties. You know, I'm the engineer in Vancouver and Derek's in the field, or maybe vice versa.
Yeah.
And we're collaborating together through this little tablet. So I see a huge
and not
value
only that,
there.
but capturing kind of the work processes as well, right? Because that's part of the problem, right? Like any company that's kind of dealing with, you know, maybe a bit of a generational gap between the new workers that are going on or established, you know, people, is like, how do I build my procedures accurately and quickly so that I can transfer that knowledge? And that has a big part to play there.
And that PTC is already there. So you can do what's called, I think it's called Euphoria.
Expert capture.
Expert capture. So you can take, you know, maybe this person is retiring, and he can just literally walk around with this head unit on his hard hat for 2-3 months, record everything, and it goes back into a little database. Somebody edits it, and now that's his work procedures for his replacement. It's all captured digitally, and they can just click and play, go through it as he's getting ramped up. It's part of your onboarding process, which you mentioned. We could do it internally, even to Apex. So it's pretty neat, the connected worker. And the next one, and it's there, and people keep talking about it, but I don't think they are aware of it in our industry, is PTC. Again, that same company that has the augmented reality has developed a machine learning, we'll say, environment for guys like us, because we're not software engineers, but they put together a nice library for you to start. It makes it a little bit more simple. You take training in this space, you get the data there, and now you can actually get that server or that database can make decisions for you, and then integrating that into your centralized control room. So those are immediate, I see, future technologies that we as Apex would be able to implement for our clients and within the next 5 years, easy. So it's pretty neat to see that, for sure.
That would be an unbelievable thing, because I brought up their website here. That'd be a pretty unbelievable thing. We talk about generational, but you get someone that's, you know, maybe they've got 3 or 4 years left before retirement, and all of a sudden a new technology comes in, it's a new upgrade. They go, no, you're fine. We've got a whole process in place there. You won't miss a beat.
You got it, exactly. And so again, the big corporations worldwide are seeing that. Coca-Cola, so you'll see them listed there. And then, you know, it's available now, and it's affordable. Believe it or not, I look at the costing, and it's like, geez, for $20,000-$30,000 in licensing, that person retiring can have a nice digital handover for the next person and the next generation. Let's be honest. Once that recording's there, you can use that over and over and over again for 10, 15, 20 years.
Yeah. Amazing. Yeah. It's, I mean, like I said at the beginning, for me to be able to get to do this show, and just go through some of the stuff with people like yourself, and I mean, so many other, you know, and it sort of starts to tie together too, right? You're talking about radar. We've talked about radar on the show with, in like waste management and things like that.
Yeah.
And you start to see the pattern of how the industry is evolving sort of at one time, but with separate companies. And it's absolutely amazing.
Oh, it's super cool. Yeah. LiDAR and radars, those type of sensors, that's a game changer for guys like us, because before we just couldn't get the visualization. We couldn't get the data.
Ultimately, you know, the operators, like before all of this, you know, machine autonomy started taking place, the way I like to think about it is the operators are operating with the control system, but with also a lot of other inputs that aren't in the control system.
Right.
And part of our job is to identify what do we need when we want to take the operator away, you know, from being at the machine directly. Right?
Yeah, exactly.
So that helps out in a big way.
Still need the same data, but you just can't be necessarily the human being piece of the data.
The human can't be the sensor.
Human can't be the sensor anymore. I like that.
So. Well, Derek, Tanner, thank you for coming on the show. I really, you know, and I say this quite often on the show because you have a lot of interesting people on, but I genuinely hope both of you come back, because I mean, we're a lot further than we were 10 years ago, but not even close to where we're going to get to. So I hope we get to keep having you on the show and going through some of this stuff.
Yeah, I think it'd be fun. We'll do
A little bit of
maybe
a check-in.
an annual update every time.
Manual,
Yeah.
there you go. That's perfect. Okay, thank you, gentlemen. And yeah, hope to see you soon.
Thanks, Jerrod.
Thank you very much.
Okay, everybody, thank you for watching. Again, this is one of those episodes. If you don't find that interesting, that would just not be your topic. It's absolutely amazing to me. Please keep supporting the show, suggesting guests to us. We want to find every layer of the mining industry and keep bringing it in and educating people and attracting people to the mining industry, and your support makes a huge difference. We will see you on the next episode of Mining Now.